So far, all the problems we've done have been one step. We used one conversion factor to convert one set of units. Now we're going to start doing two-step problems. And these are mass to particle problems. This example says, what would be the mass of 3.75 times 10 to the 21st atoms of iron? You can tell that this is a two-step problem because it doesn't have the word mole in it at all. It asks for mass and it gives you atoms. So that's kind of a hint that you're going to have to do two steps because we don't know a relationship between mass and atoms. We know one between atoms and moles, and then moles and mass, but we don't know one relationship between those two units. So we know, because atoms is a representative particle, that we're going to have to use 1 mole of iron equals 6.02 times 10 to the 23rd atoms of iron. We also know that if we want to get to mass, we're going to have to use molar mass. 1 mole of iron, and we can look at our periodic table, equals 55.85 grams of iron. That's our 1 mole equals molar mass. So now we're just doing dimensional analysis in two steps. We start with our 3.75 times 10 to the 21st atoms of iron. If we're trying to get rid of atoms, that means we have to put atoms on the bottom. So we put 6.02 times 10 to the 23rd atoms of iron here, and 1 mole of iron on the top. Now some of you might have this question that if atoms equals moles and moles equals grams, why can't we just say atoms equals to grams? And you can, but it's really going to mess you up when we get to the next type of problem because we're going to need that moles in the middle. So please just practice going to moles first and putting in that extra step now. It will pay off later and make your reaction stoichiometry a lot easier. So when we do 3.75 times 10 to the 21st divided, make sure you put your scientific notation in parentheses. So you get 0.006229 moles of iron. At the end, we're going to have to worry about significant figures. I'm not going to worry about it in the middle. My only suggestion is don't round away numbers that are going to be significant later. What I actually do is I just leave this 0.006229 on my calculator and do the next math without having to do any rounding at all. That's the best way to do it, honestly. So just leave it in your calculator and do the next step on top of it, and you can write a shorter number, a rounded number here if you want to. You don't have to write the whole number out every time, but it's better for your math if you leave the whole number in your calculator. So we have moles, but we're not asked for moles, we're asked for mass. So we start by writing what we know, 0.006229, and again you can write 0.0062. As long as you keep all those extra digits in your calculator, it won't make a difference. We're going to do times the conversion factor. We're trying to get rid of moles, so 1 mole is going to go on the bottom. And because we're trying to get to grams, we're going to put our molar mass on top. 55.85 grams of iron. Cancel out our moles, and then do our times 55.85, and you should get 0.347903 grams. And let's talk about significant figures. This number has 3. This number has 3. We don't have to worry about this number because we left all the digits. And this number has 4. So our answer has to be rounded to 3. So we have 0.348 grams of iron. So if I asked you to get me 3.75 times 10 to the 21st atoms of iron, you could go to a scale and get the mass of 0.348 grams. This question asks, if I had 54.0 grams of water, how many molecules of water would be in that sample? We know that this is a two-step problem because it asks for molecules and gives you grams. It doesn't say mole in the problem at all. So we know we're going to have to use both of our conversion factors. We're going to have to use 1 mole of water equals molar mass, and we can look at our periodic table and find our molar mass. We have 2 hydrogen, that's 2.02, plus 1 oxygen, that's 16, so it gives you 18.02 grams of water. And in order to get to the molecules, we're also going to have to use 1 mole of water equals 6.02 times 10 to the 23rd molecules of water. So now we're just doing dimensional analysis. We always start by writing down what we know. 54.0 grams of water. Because we're trying to cancel out grams of water, we have to put the molar mass on the bottom so that those units will cancel. And we have 1 mole on top. Our grams cancel out. And we do 54 divided by 18.02. And that gives us 2.99667. You don't have to write it all out, but I would like you to keep all of it in your calculator. It'll make your final answer more exact. So the next step is to go from moles to molecules. We're just taking these 2 types of problems we've already done and combining them into one question. So 2.997 moles of water. If I want to get rid of moles, I have to put mole on bottom. If I want to get 2 molecules, then I have to put 6.02 times 10 to the 23rd molecules. Our moles cancel out. And when we multiply our numbers, you get 1.804 times 10 to the 24th. If we look at our significant figures, this number has 3, this one has 4, and this one has 3. So we're going to round our answer to 3 significant figures, and that will give us 1.80 times 10 to the 24th molecules of water.